So the first thing we need to do is rewrite this in a nicer form. So basically that is the same as tan of 2x is equal to 1 over x squared. Both of these are graphs that we can draw relatively simply. Okay, so remember that tan 2x is basically tan of x over a half. So it is a stretch by a factor of a half, or a squashing by a factor of 2. So let's first of all draw tan x. This is tan x, and this would be pi over 2, and this would be minus pi over 2. But as we are squashing it to get tan 2x, this is therefore pi over 4 and minus pi over 4, which means that the period of the pattern is pi over 2. So therefore it goes through the zeros at 0, pi over 2, and pi, and minus pi over 2, and minus pi. So we can now draw tan 2x is going to be looking something along the lines of this, up to pi. Remember, we're only interested between minus pi, and then we have to go down this side as well. So it looks something along the lines of that, and then pi comes here, and this bit is outside of the range, and this bit is outside of the range. All we need to do now is draw y equals 1 over x squared, and let's just change the colour of the pen to do that. Y equals 1 over x squared is basically an even function. It's symmetrical about the y-axis, and it looks something along the lines of that, although it's not exactly symmetrical. And we can clearly see there are 1, 2, 3, 4. They should be symmetrical, but I haven't drawn it properly. Answers. So the answer is C. There are 4 real solutions.